Oops. 10. Last time the red was evil. Last one evil. Okay. So we're going to be learning about, wrap it up, Josh, so you can catch up with this. So we're going to be learning about sequences today. Have you guys ever seen like brain teaser questions where they have like a bunch of numbers and they have a blank and you're trying to figure out what that number is? Like if you see a pattern, you have to figure out what the pattern is and then finish it. That's essentially what this is. We're looking for patterns and we're finishing like a string of numbers with that pattern. So we're going to be learning about two different sequences: arithmetic sequences and geometric sequences. This is pronounced arithmetic because this is the adjective. Arithmetic is a noun. Arithmetic is the adjective. Alright, so it's pronounced arithmetic when you're using it as an adjective. A sequence is just a list of ordered numbers separated by commas. But they're not just randomly set on a piece of paper, they have a pattern. Right? You're adding or multiplying something to create that pattern. So an arithmetic sequence is when you're adding something to create the pattern. So an arithmetic sequence, already, really. Give me 1 second. I need to set this without moving. There you go. Lock the page in place. Not a good sign, but alright. So an arithmetic sequence is when you guys are adding something called the common difference. Common difference. Which is called D. Called D. We're going to be adding that to all of the previous numbers, right? So you have a list of numbers, and the way that you're creating this pattern is you're picking a number, and you're adding that onto each number as you're going along, right? That's what an arithmetic sequence is. Now, in order to figure out what that number is that you're adding on, that is something you guys have to be able to figure out. Like, what is it that I'm using to add on to the numbers to create my pattern? And that's called D. When you guys see D, the symbol D, that's what they're talking about, this thing that you're adding each time. So here's an example of an arithmetic sequence. What am I adding each time?
150.
150. How'd you figure that out?
The first one was 115.
So how'd you know you were adding 115? Say again? You said what, in what direction? Backwards. So in order to figure out how to move forward, you subtract backwards. Right? It's just like history. You think about your past in order to be informed on your future. So that's how a sequence works. When you guys are, I'm going to skip down here to this step. The common difference is represented by, it's already happening. This is not good. I don't know why my board does this to me. So mean. Maybe if I use a different color, it'll be fine. Nope. Alright. Hold on. Anyway, you guys finish the sequence. You guys know what the pattern is, so go ahead and finish it for me. Anybody know what those last two numbers would be? 900 and then some relatively big number, right? For, what is it? 1,000.
150.
1050, there we go. Right, and so what I was trying to do down here was D, and the way that you find the common difference is subtracting backwards, like what Jonathan was saying. Subtracting, sorry, I'm in front of the board. Subtracting backwards. So in order to go forward, you need to look back first. Right, so to find the common difference, to find the change between the numbers, you have to subtract backwards, and once you figure out what that is, you can keep adding it forward. The first term in this sequence, what is the first term? It's 150. The first number that you guys see is 150, and that's represented with A sub 1. A sub 1. Right? A sub 1 tells me that it's the first term, so what would A sub 2 be? 300, the second term, and A sub 3? 450. So A represents the term. I don't know why they don't use T. That would make a whole lot more sense, but they use A. So A represents the term in the sequence, and the little number next to it tells you which of those terms that you're looking for. What if I said A sub n?
Any number in the sequence?
It's any number in the sequence. How do you tell which one it is? you replace n with a number, right? So this is the general term anywhere in your sequence. N just is a variable that you can swap out with a number. We call it the nth term. It could be the second, the third, the fourth, whatever. You just swap out n with whatever your number you want, and that's how you get to that number in the sequence. In a finite sequence, a sub n is typically considered the last term of the sequence. Do you guys know what a finite, or what finite means? It has an end. As opposed to infinite, which keeps going on forever, a finite sequence has a clear start and stop. We're going to talk about infinite on next time, how we work with those to evaluate, but for now we're probably going to be focusing more with your infinite sequence, or sorry, your finite sequence. So a sub n is just some random number in your sequence that you can find by replacing n with some number. Right, here's a new example, example number 2. I have 0 blank, -8, -12 blank.
Adding 4. No, subtract 4.
You're adding something. You want to always say it in terms of adding, but what is it that you're adding? You're adding -4. Remember, the way you find that is you pick 2 consecutive numbers and you subtract backwards. They have to be consecutive. So you pick 2 consecutive numbers and you subtract backwards. So -12 minus -8 is -4. So that's what you're adding to go forward. So if I start at 0, what would my next term be? -4, and then adding another gets you to -8, -12, and then -16. So that's something you guys need to know how to do. Figure out what the pattern is, what are you adding each time, and then finish it if you have books. Is everybody okay with that? Cool. Alright, this is one of our first formulas. I want you to circle it so you can see it in your notes. Right, on your formula sheet, I'm just going to show you guys where it is really quickly so you guys can see. On your formula sheet, the sequence stuff is right here, the arithmetic, and the formula that we're going to be talking about right now is the first one. Right, so if you're ever looking for it on the formula sheet, that's where it is. But I'm going to have it written down here so you guys can see. Alright, so here's our first question. What's the 16th term of the arithmetic sequence that's provided? Alright. You wouldn't want to have to write out all 16 numbers, would you? That would take forever, especially if they ask for like the 100th term. You don't want to be writing numbers over and over and over again to get there. So that's what this formula is for, right? If they tell you where they want you to go, you just have to use this formula, plug in what you know, and solve for what you don't know. So in here, what have they given us? Well, first of all, here, let's look at the formula. In order to find a sub n, which is some number in the sequence, you need to know the first term, how far you want to go in the sequence, and what the common difference is. So looking at this example, do you guys know any of those things? Do you know the first term?
150.
Okay, so I'm going to write down what I know. So the first term is 150.
The n is 16.
N is 16. Now remember, n represents how far you want to go in the sequence. So if you need to write some extra notes to remind you, n represents how far you need to go in the sequence to get to a sub n.
And the common difference is 150.
Yeah, so this is the sequence we were talking about earlier. The common difference is 150, and remember the way you find that is subtracting backwards. So are those all the 3 things that I needed for the formula? Yeah. So I'm trying to find a sub 16. I'm trying to find the 16th term. That's how you say the 16th term in notation, a sub 16. So all I have to do is plug everything that I know into the formula. The first term is 150, n was 16, and d is 150. If you want to do that mental math, you can turn the 16 into a 15 automatically, because 16 minus 1 is 15. Feel free to do that. And then all you have to do is plug that in your calculator.
2,400.
You should get 2,400. Right, that's how you use the formula. They will give you everything you need in the problem. You just have to find it. Alright, this one's just like it. What do I know?
Everything.
Like what?
A1 is 1.
Okay, the first term is 1.
N is 28.
28, where did you get that?
You look at the thing and say a sub 28.
Yeah, a sub 28. What am I looking for?
Your distance
The-
that you're going.
No. What is, how do I say it? Like, what does a sub 28 represent?
The 20.
The 28th number. It's the 28th number in the sequence. That's what a sub 28 represents. So we know we're going out to the 28th spot. That's what n represents. What spot in the sequence are you going to? What else do I know?
You know these three, you're adding three. You
Yeah.
just have to look at the sequence.
Yeah, we look at the sequence. I'm adding 3 each time, right? So that's what the common difference is. So now I just plug everything to the formula. A sub 28 equals the first term plus, what was that? I'm just going to go ahead and write 27. I can do that mental math. 28 minus 1, 27. And you add those together. What do you get? There, you should get 82. Alright, so everybody see how we do that with the formula? Okay. Switching it up just a little bit so it's not so mundane, I have a word problem here. Julio earns 15 points on day 1, 17 points on day 2, 19 points on day 3. If this continues, as we're seeing here in this pattern, how many points will he have at the end of 2 weeks? How would I approach this?
First you would look for your A sub 1, which
Okay.
would be 15.
Alright, so A sub 1 represents the first term, and so that's the first number we have in this pattern.
And 2 weeks is 14 days, so
Okay.
14 is your N.
Did everybody catch that? They were talking about days before, now it's weeks, so you have to convert that. Okay?
And then they're doing 2 points every day. So
Yeah.
you common difference too.
Yeah, the common difference is 2 because you're adding 2 each time. Right, so now I'm trying to find A sub 14. I'm trying to find the 14th term. That's 14 days, right? The 14th term. So you start plugging everything into the formula. The first number was 15. Since n was 14 and you subtract 1, you get 13 here. Common difference goes at the end. Stick it in your calculator.
390.
Um,
No, wait.
Nope.
I multiplied instead of
should be 41.
yeah, not 44.
Right? So everybody see how it's pretty straightforward, right? That's just the use of the formula going that way. Everybody good with that? Alright, so that's the straightforward use of the formula. Now we're going to learn how to go backwards. You need to know how to use this formula forwards and backwards. So they may give you everything and ask you to find A sub n, or they may give you A sub n and ask you to find one of the other variables, like A sub 1, or d, or n. Okay? So in this one, they say that 23 is the blank term of the sequence defined by this formula. What do they want us to find? Nope. The blank. We're trying to fill in the blank here. They're trying to figure out where it is in the sequence. What variable tells us where it is in the sequence? N. N represents how far you needed to go in the sequence to get to that number. So what we're trying to find here is n. Since they're asking us which term it is, n tells you which term it is, how far do you have to go in the sequence to get there. So we're trying to solve for n based on this. They've given us the formula already written down. So how do you think I would solve for n? What's this?
That's the number of the sequence. Like that's the answer to how many numbers.
This is the nth term.
Yeah.
You have like number, and then 23. So what does 23 represent? Think about the variables. A-N. Remember how I said up at the top we were defining everything? I said A sub n is the last term in a finite sequence. We have to remember that here. Whenever they give you a specific number that you're going up to and then stopping, that's your last term. That's going to serve the position of A sub n in your formula. So now I have this formula here, right? Now I have A sub n and n. What is it that I'm trying to solve for? N. That means that you're going to put the 23 where? In the A sub n. So we're going to write 23 is equal to 2n plus 11. And then you solve algebraically. Really quick 2 steps. Subtract the 11, divide by 2. 6. So 23 is the 6th term of the sequence. That's how you solve backwards. The number that they give you here is A sub n. They're telling you where you go in the sequence and stop, and then you have to kind of think how far did you have to go in the sequence to get to that number. You're solving for n in that situation. Okay? Same kind of question here, but instead of giving us the formula, they're giving us the start of the sequence instead. Okay? So 0 is the blank term of the sequence, blah, 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 blah. What are we looking for? What do they want us to find? N, the n. We're still trying to find what term is 0. How far do I have to go in the sequence until I get to 0? That's n. That's what n represents. What is 0? What does 0 represent? That's a sub n. That's our last term that we're going up to, so it serves the purpose of the last term, the a sub n. Alright, so what I'm going to have to do is now I have to start plugging everything that I know into the formula and solve for what I don't know. So I know that a sub n is 0. I know I scrolled down so I can't see the formula anymore, but you guys can see it. A sub n goes here. What comes next?
Negative 117.
Negative 117, a sub 1, the first term.
Parentheses, then like x or whatever.
Do you know what n is?
No.
So that's going to stay a variable. It's going to stay a variable.
Your last number, you have to look at the sequence to know that's 13.
D represents the common difference. What am I adding each time?
13.
I'm adding 13. And remember, the way that you find that is subtracting backwards. If it's not immediately obvious, just take two consecutive numbers and subtract backwards, and that's how you find it. And how do I solve for n?
Now you would add, you have terms.
Okay, so you're going to do just a little bit of algebra, add the 117 over. You get n minus 1 times 13.
And divide by 13.
Divided by 13, I believe that's 9, if I remember correctly.
Yeah.
And then what?
And then add 1.
Then add 1.
You get n equals 10.
So n is 10, so it's the 10th term. It's the 10th term. Both Sebastians. Heads up, please. See you guys. Oh, I hope you're asleep. Pay attention, buddy. Alright, so it's the 10th term. Alright, everybody try the next one on your own. Everybody try the next one. Alright, does anybody think they know what the answer is? Frankie?
11 equals n minus 1. Yes.
I want to know what n is. Finish it, you have one more algebra step. It's 12. So 72 is the 12th term. You guys should have gotten 12 for n, which means that it's the 12th term. Did everybody get 12? Yes? Everybody's good? I don't have to show the work for that one. Everybody's good? Alright. This next one is different. So the ones that we just talked about, the way that you guys use that formula, you have the forwards way, which is really easy, then you have the backwards way, which is what we were just practicing. This one's a little bit different. If you guys see that they're asking for an explicit formula, it means that they want you to write down a formula and then simplify it as much as you can. So the formulas that you're going to see in the answer choices are not going to look like what you would expect because they've done a little bit of algebra to simplify it. So what we're going to do is practice doing that here so you guys know what it looks like. So I'm trying to write the formula that will get this sequence right here, alright? So I'm going to start with a sub n. We're using the formula, okay? A sub n is going to pretend to be our y. So I'm going to write y underneath it. We're basically writing a y and an x in there. They're just different variables according to this formula. So a sub n is going to be like our y. We don't know what a sub n is, right? We're trying to write a formula in general that will give you what the value of y is. Please don't. Give me 1 second. I don't know why it chooses random times to do this. There we go. Right? What else do I know about the sequence just by looking at it?
First number is -3.
I know the first number, right? So a sub n is -3, right? Plus, now do I know what n is?
No.
N is some random number that you would plug in. So I'm going to leave that as a variable. This is like our x.
And D is 8.
N is like the x. You're plugging numbers in for n, or the x, to figure out what y is. It's the same thing, we just have different variables here. Now do I know what d is? Do I know what the pattern building number is?
You're adding 8.
I'm adding 8. So this is what it would look like when you guys plug stuff in initially, but this is not what your answer choice is going to look like. I want you guys to do a little bit of algebra to simplify this. What's something I could do algebraically to neaten this up? No? I'm not trying to solve it, I'm just trying to neaten it up. Distribute the 8. So it would be -3 plus 8n minus 8. A little bit more.
Now you can add 3.
Now you can add this -3 and the -8, and you get 8n minus 11.
Yeah.
That's what they want. That's what they mean by explicit formula. They want you to actually do the algebraic property that's represented here, the multiplication, and then simplify it so it looks like that. So it's going to look like a y equals mx plus b kind of thing, and the way that you get that is by distributing through the parentheses and simplifying like that. Okay, so just in case you guys see that somewhere, I just want to make sure you knew how to do that. Alright, one more application of the formula, and then we'll go on to the other type of sequence. So we have this thing called arithmetic means. It's like an average, but there's more than one. So it's like multiple averages. Do you guys see this example right here? Do I have any consecutive numbers next to each other?
No.
No. They're like bookends. I have two numbers and a bunch of empty space in between. So is there any way I can find out what D is?
No.
Can I subtract 14 minus 8 and find D? No, because the way you find D is by subtracting consecutive numbers. They have to be next to each other. So our job, when we're trying to fill in a sequence where you have this huge gap, we're going to have to find D in a different way.
Finding the formula.
Yeah, so what you're going to, the arithmetic means are the terms between non-consecutive terms. So if you have that bookend situation with a lot of space, what you're going to do is plug in a sub 1, a sub n, and n into the formula. Spell that wrong. Into the formula. In order to do what? What do you think we would, when you plug that in?
Solve the formula, and then you can figure out another number to complete the sequence.
Fine. We're looking for D. That's the number that will help us complete the sequence. And before we could just find D by subtracting consecutive numbers, we don't have any consecutive numbers, so we have to use the formula in a different way. So we're going to plug in what we know and solve for what we don't know, which is D. So looking at this, can you guys tell me what these numbers represent?
And 8 is a sub 1.
Okay, so we're going to go ahead and label everything. So 8 is a sub 1.
14 is a sub n.
Yes. Remember, we keep treating a sub n as the last term in our finite sequence.
Then isn't like most of them n?
No. What does n represent again? What does n represent? How far in the sequence you went to get where? To the last term, a sub n, right? N tells you how far you go to get to a sub n. Well, didn't we say 14 was a sub n?
Yeah.
How many terms is that in the sequence? 1, 2, 3, 4, 5. So n is 5. That's what n tells you. It tells you how far you go to get to the last term, or the term that they're referencing in the question. And here our last term is 14. So to get to a sub n, you have to go 5 terms to get there. So now I know all those things. I'm just going to plug them into the formula. What is a sub n? 14. Why did you do that? 14 equals what will come next?
8.
8.
Then parentheses 4. We already did the subtraction.
And then we're going to call it d because that's our variable. I just turned it straight into 4 because in the parentheses it should be n minus 1. 5 minus 1 is 4. Great, everybody should be writing this down. Let's go. Josh. Yes.
So now you can subtract.
1, 2, 3, 4, 5. Right, now what?
Subtract 8.
Subtract the 8. 6.
Good. Divide by 4.
You get 1.5. So what do I do with the 1.5?
You plug it into your current
What do I do with it?
Sequence.
Keep adding.
Keep adding it. Keep adding it. So what's 8 plus 1.5?
9.5.
And then add another one.
11.
And then add another one.
12.5.
12.5. Alright, once you get here, you have to make sure that that jump is valid. You have to make sure that if you add another 1.5, you get to 14. Do you?
Yes.
Yes. If you guys mess up here, right, you guys could have messed up and said it was like 1. And you would have done 8 plus 1 is 9, then 10, then 11. If you don't check this last step, you don't know if you did it right or wrong. You can add anything you wanted to fill in these blanks, but you don't know if you're right or wrong unless you know that you can get that connection to happen between these last two numbers. So that's always what you guys need to check. Make sure that as you're filling in those blanks, you have that correct connection between the last jump there in your sequence. Okay? You guys want to give the second one a shot on your own? Go ahead and try that last one. Excuse me, guys. Alright, so anybody found D? Actually, 5 for D. Did everybody get 5? Alright, so that means you're just generating the sequence by adding 5 a bunch of times. 13, 18, and then always double check that last jump there that you would get to 23 if you added another 5. Alright, is everybody good with arithmetic means? Any questions? Alright. We're going to do all the exact same stuff that we just did, but for a new type of sequence called geometric sequences. So for arithmetic, you add. What do you think you do for a geometric? Nope. Multiply. We already took care of add subtract. Add subtract was for the arithmetic. For a geometric sequence, you're going to be multiplying. Sorry, I'm in front of the board. Multiplying by something called the common ratio, which is represented with an R. So arithmetic is add subtract. You add to go forward, subtract to go backwards. Geometric is multiply divide. You multiply to go forward, divide to go backwards. Alright, so we're taking care of all of the operations. So this is an example of a geometric sequence. What am I multiplying by each time? I'm multiplying times -2. See how the signs are alternating? You can see that? Positive, negative, positive, negative. That can only happen for a geometric sequence. Because you're multiplying times a negative number. A negative times a negative is a positive. Positive times a negative is a negative. And so it alternates signs like that. Again, the common ratio symbol is R. And then how would I find that? If I multiply to go forward, how do you think I would find what R is? Divide backwards. Dividing backwards. Right, so for example, if you weren't quite sure what the ratio was here, you can take any two consecutive numbers and divide backwards. So you could have done 8 divided by -4, gives you -2. You could have done 32 divided by -16, still gives you -2. So you just pick two consecutive numbers and divide backwards, and that's how you find R. Alright, so what about this one? What's the common ratio? What am I multiplying by? I'm multiplying by -7. You can find that by taking any two consecutive numbers and divide backwards to the left. So if I keep multiplying times 7 to go forwards, then what would my next number be? You multiply times -7, you get -343, and then multiply again.
2,101.
Okay? What about the next one? You have to find two consecutive numbers, and then divide backwards to figure out what the ratio is. Divide backwards.
0.5.
Yeah, it should be 0.5. Whatever you get when you divide backwards, that's what you're going to multiply times. So we're multiplying times 0.5 each time. So if I start with 60 and then multiply times 0.5, what do I get?
30.
30. Multiply times another?
15.
15. And if you keep going, if you multiply that times 0.5, that's how you get to the 7.5. And then 3.75. Right? So divide, go backwards, multiply to go forwards. Alright, so we have a new formula when we're working with the geometric. And it's right here. On your formula sheet, that would be in the right column at the bottom. There are a couple